Okay, so this question is quite a high scoring question. It's worth 5 marks, so they're expecting quite a bit of work. And we look to the question and we can see there's about 2 triangles. It's telling us about the area. So that's kind of saying to us, what do we know about area of triangles? Well, we know there's a formula when we're working with angles and lengths that are not 90 degrees. Then we use the half AB sine C. And they're asking us to work out the length of AB. So AB is this length here, so that's going to be our kind of question mark. Because they're talking about this particular information, then it's kind of crying out at us that we should be looking to use a side angle side triangle. So if we look at the triangle that's defined by this area ACD, then we can see that we've got the angle of 105 degrees. So they're basically saying to you here, calculate the length of DC. It might help you do the rest of the question. So if we get the length of DC first, that would be useful. So we can say that the area is 56, and that's equal to a half. Well, A and B are just defined as the 2 side lengths. So that's going to be a half times 11 times the length of DC. Times the sine of the angle between them, and then we just rearrange this to give us the length of DC. So DC, take the 2 over by timesing, so it's going to be 2 times the 56. We're going to take the 11 across by dividing, and we're going to take the sine of 105 across by dividing, because it all says timesing here. So that'll give us the length of DC. So 2 times 56 equals, and then we're going to divide that by, we're doing 2 calculations, so put in a bracket, 11 times the sine of 105, close the bracket, press enter. So we get 10.54, and because they want the answer, the final answer to 1 decimal place, then it would seem sensible to do this to 2 decimal places as we're working through, and then we can see what's going on. Okay, so we can now add that onto the picture. Always useful to add on new information so we can kind of see what's going on. If I want to get this length here, it's opposite an angle, so it's kind of shouting out at us, use sine rule, which if you remember, because you should know your formulas guys, practice, so make sure you do. Then this is about lengths and opposite angles. So it looks like to me then we need to be finding this length here, because then we will have an opposite length there. So we need to be working out the length of AC. But we can see in this triangle that if we've got 10.54 there, then we have a side angle side triangle where we know 2 lengths and an angle. Therefore, to get the 3rd length, we're going to use the cosine rule. So this is now telling us to use the cosine rule. So to get the length of AC, it's going to be squared, because the cosine rule says you square. And it's going to be equal to the length of AD squared plus the length of DC squared, take away 2 times the length of AD times the length of DC times the cosine of the angle between the 2 lengths, so in this case 105 degrees. So just remember the cosine rule, so A squared equals B squared plus C squared minus 2BC cos of big A, the angle. So just using that as our kind of background, then we can fill in the information. So we know now that AC squared is going to be equal to AD squared plus DC squared, take away 2 times those, times the cosine of 105 degrees. Okay, so we've got 11 squared plus 10.54 squared, take away. Now, because we're doing lots of operations in this takeaway bit, I prefer it in a bracket. Most calculators you don't need it, but I tend to do that. So 2 times 11 times 10.54 times the cosine of 105 Okay, so AC squared is going to equal 292.1065. To get the AC length, then we'll need to square root that. So we square root. Okay, so second function square root second function answer equals So 17, again, keep it to 2 decimal places while we're doing the workings. So that gives us 17.09. Alright, so that gives us the length of AC now, so we can add that onto the diagram. And now we can see that we do have enough information to use the sine rule. So basically the sine rule says, and because we want a length, we'll keep it on the top. So the length of AB and its opposite 48 over the sine of 48 degrees is going to equal the length of AC, well we know that's 17.09, over the sine of 118 degrees. We want the length of AB, so we're now going to just rearrange this by taking this across by timesing, because that's a dividing. So 17.09 times the sine of 48 degrees all over the sine of 118 degrees. Okay, so we put in our calculator. So we've still got that there, so times the sine of 48, so sine 48 equals, and then divide by the sine of 118 equals, so 14.38. Now the question said to do it to 1 decimal place, so our answer on our answer line will be 14.4, and the units of this question was meters, so it'll be 14.4 meters. Okay, so this question came down to recognising that we have some triangles, and if we're going to use this formula for the area, it's about a side angle side triangle. So that kind of shouted out at us, work out the other side length, because we knew 3 bits of the information but not the 4th one. And once we got that length, we then recognised that to get the other length, we've got a side angle side triangle, cosine rule. Use the cosine rule, got that length, and then we recognised we've got lengths and opposite angles involved, and then we can use the sine rule. So a nice question involving the use of all those different rules, and giving you a final answer of 14.4 meters.